Hello kids, let's do this chapter prime time from RS Agarwal book, and in RS Agarwal it is chapter number 4. So again what we are going to do here is all the portions which we have already covered, the questions which we have already covered, we are going to skip them. That is a homework for you, and rest of the questions we are going to do now. Okay, so the first question is define factor multiple. Find all the factors in first 5 multiples of 20. So we know that what is a factor and a multiple? A factor is a number which completely divides the another number. This we have already done in the very first lesson of this chapter. Again, I'm taking the example. I'm taking the example of 20 only. Okay, so let us try to find the factors of 20. So factors are what? They are the numbers which completely divide the other number. That means it doesn't leave any remainder. So the factors of 20 are 2, 5. Okay, this is 2 and 5. And again we have 2. So these are the factors, that is 2 into 2 into 5. So these are the numbers which completely divide 20. Right? And then we have multiples. So when we will take multiples, I'm just writing multiples here. What are multiples? Multiples are the number which are obtained by multiplying that number with the another whole number. So if I want the multiples of 20, it will be 20 multiplied by 1, which is 20 only. 20 is the first multiple of 20. Next we have 20 multiplied by 2, which will give us 40. 20 multiplied by 3, 60. 20 multiplied by 4, 80, and 20 multiplied by 5, which will give us 100. So these are the first 5 multiples of 20 which are being asked. So again, what are the multiples? Multiples are the numbers which we get by multiplying the number, of which we have to find the multiples with the whole numbers. All these are the whole numbers here. Okay, and these are the multiples, right? This we have already done, multiples and the factors. Now let us go to the next question. First is done. Write down all the factors of these numbers. So again kids, these are very easy. We have covered it many a times. Still I am taking two numbers here and let me find out their factors. So I am taking 84 and I am taking 125. Rest of the questions are homework for you because we have done it many times. The more you practice, the more easy you will feel in doing these questions. So you have to practice again and again. Okay, so question number 2, I am taking the sixth part, which is 84. So what we will do, we can do it with prime factorization because we know now that what is prime factorization. Okay, so let's do one thing. Let's try to do this with that method only. So if I take 84, 84 has the first multiple, it has 12. The second multiple, it has 7, right? Because we know that if we multiply 12 with 7, we will get 84. Now what we will do further? Again, we will find out the factors of these two numbers till we are left with only the prime numbers. Okay, till we reach to the point where we cannot further break them down. Now the factor of 7 is nothing. It is only 1 and the number itself. So I am writing it is 7 and 1, right? Because it's a prime number. Coming to 12, 12 again has two factors, that is 2 and 6. So when we talk about 2, this is the end to it because it cannot be further broken down, and the other one we have 6, and we know that we can break down 6 further. This is 2 and 3, right? So these two, this 2 and this 3, these are the prime factors. We cannot break them further. So our total factors of 84 are this 2, right? This 2 and this 3, this 7 and 1, of course, right? We'll have 1 everywhere. So I'm just taking 1 here. So if you multiply these, you will get this number 84, and these all are the factors of 84, right? We have used the prime factorization method here. Now let us move to the another question. Let us find the prime factors of 125. So here we have 125. So kids, 125 I'm writing here. 125 has how many factors? See, we have 5 and 25, right? And then we cannot break it further. We are left with 25. We can again break it into two parts, that is 5 and 5. Okay, because we multiply 25 with 5, we will get 125. So its two factors are 5 and 25. This 5 cannot be break down now because it's a prime number. Similarly, this 25 can be broken into its multiples, its factors, which are 5 and 5 again, and these two fives, they can again not broken down further. So what we can see here is, what are the factors? They are this 5, this 5 and this 5, the one at the ends. We have to write them all. Okay, this is done. Now let us move to question number 3. Write first 6 multiples of each of the following numbers. So kids, this question I'm marking as homework. This is very easy, like how I have done it for 20. I have find out the first 5 multiples, and if you have to find the first 6 multiples, what you have to do, you have to take this number. Like if I take example of 13, so you have to do 13 multiply by 1, it will give you the multiple, and this you have to do for the first 6 multiples, that is till 6. You have to do till 13 multiply by 6. You have to find the multiples. Same you have to do for all the numbers. For all the numbers, you have to find out the first 6 multiples. Okay, so you have to multiply them with the whole number starting from 1 to 6. Now, without actually dividing, show that 11 is these all are the factors of this numbers. Okay, so kids, these are also very easy. We have already covered it. Again, I'm going to take 2 examples here. Okay, what examples? I'm taking example first and I'm taking example 4. So I'm writing question number 4, A part here. What is it? It is 11 is a factor of 1111. So we have to find this, that it is a factor of this. So kids, how you can do this question here is see, we have this number 1111. Let's try to break this number. Okay, we can break this number and write this as 11,000 1100, sorry, it's 1100 plus 11, right? We can always write this number as this. And now again we have 1100 plus 11. In both the numbers we have 11 common, so we can take out 11 common, and then we have a bracket, and inside the bracket we have to write this number 100 plus 1. Correct? Because if you multiply this, you will get the same number. So what we have done is, from this 1111, we have taken out 11 common. So we can clearly see here that one of the factor is 11 here, and the another factor here is 101. So that means 11 is a factor of this number. Okay, so I hope you understood this. Let me again tell you what we have done. We have this number and we have broken this number into 2 parts. So we have done 1111. We have written this as 1100 plus 11. Okay, and from here we can take out 11 common, and inside this we have 100 plus 1. So this will give us 11 here and 101 here. We have these two as the numbers given to us. So Since we have one of the factor as 11, that means 11 is a factor of 1111. Okay. Now the last question D, where we have to see that 21 is a factor of 21063. Okay. So how we are going to do this? Again, we are going to split this number. So we have 21063. We can write this number as 21,000 plus 63. If you add this, it will become this number, right? So we have this number. And kids, if you see here, we have 21 common. I can write this number as 21,000 here. And if you will multiply 21 with 3, you will get 63. So that means I can always write this number as this. Okay. So again, I have 21 as one of the factors. And another factor we have here is 1003. So that means 21 is a factor of this number given to us. Okay. So in the similar way, you can do the rest of the question, the third and the second and the third part. Next, which of the following numbers are even and which are odd? So kids, this is very easy. This is a grade 2 question. Okay. And we can easily do this. We know that the number which is divisible by 2 is always a even number. Okay. So 32 we have is a even number. 37 is odd number. 50 is even again. 58 is even. 69 is odd. 144 is even. 321 is an odd number. 253 is an odd number. Done. Next, what are prime numbers? Give 10 examples. So kids, we have done what are prime numbers. They are the numbers which doesn't come in any, which is not a multiple of any number. It has only two factors. This number, the prime numbers, they have only two factors. That is, what are those factors? That is 1 and the number itself. Okay. It cannot be broken down into the another smaller numbers. It doesn't come in any table. Okay. And it always have two factors, 1 and the number itself. Next, what all are the prime numbers between 1 and 30, 30, 60, 60 and 100? Kids, we have done the complete chart from 1 to 100. So I am again giving this question as a homework because we have done this. Okay. Next, find which of the following numbers are prime. Same, a part of this we have already done. From 1 to 100 we have seen what are the prime numbers. Okay. So again, I'm leaving to you this question. I'm giving it as a homework. Write the smallest prime number. So what is the smallest prime number, kids? We know that 1 is neither a prime nor a composite number. Composite numbers are what? The non-prime numbers. The numbers which have factors other than 1 and the number itself. They have more factors. They are composite numbers. This we have done. Now the smallest prime number is cannot be 1 because 1 doesn't come in prime or composite. Okay. So the smallest prime number is 2. List all even prime numbers. This we have already done. 2 is the only number which is even in prime, because if we'll go to the next even number, which is 4, that is not a prime number. It is a multiple of 2. It has a factor 2. Okay. This also we have done. Now write the smallest odd prime number. Again, this is 3. 3 is odd and it's prime also. And write the smallest odd composite number. So kids, what is the smallest odd composite number? That is, it cannot be 5 because 5 is not a composite, it's odd. It cannot be 7, right? Why? Because 7 is not composite, although it's odd. Coming to 9. 9 is what? 9 is odd also and 9 is composite also because it has factors other than 1 and 9, and that is 3, right? So this is the smallest odd composite number. Now, is there any counting number having no factor at all? So What does this mean? This means that, do you know that any number which has no factor at all? Yes. And what are those numbers? They are the prime numbers. They don't have any factor other than 1 and the number itself. But if they say no factor at all, then no. The answer is false. No or no. There is no such number which doesn't have any factor, because all the numbers are either prime or composite. So they have at least one as a factor and the number itself as a factor. Find all the numbers having exactly one factor. So all the numbers having exactly one factor. So we have already, always we have two factors, one and the number itself. So the lowest number of factors will be 2. So we can write no such number. Okay. Next, what are composite numbers? We know that composite numbers are the numbers which are non-prime, okay, which have factors. Can a composite number be odd? So yes, we have seen the example of 9. It is composite and it is odd also, right? If yes, write the smallest odd composite number. Again, it is 9. We have done this. So kids, what are twin primes? We have done. I am leaving it to you. What are co-primes? This also we have done. Again, I'm leaving it as a homework, but you have to practice it again. Okay, so it will help you to remember all these. Next, express each of the following numbers as the sum of two odd primes. So what we have to do here is, kids, let me do this question. So kids, I'm writing this here, question number 14, and let us do the first two parts, this one and this one. Okay, so the first part is 36. What we need to do here is, we have to express them as the sum of, that is addition of, two odd prime numbers. So two numbers, first of all we have to tell two numbers, both the numbers should be odd and both the numbers should be prime, and the addition, that is the sum of both the numbers, should give us 36. Okay, so let's do this. We know that 36 is what? 36 has half 18. We cannot use 18 here because 18 is a even number here. So how we can express this 36 as? We can take this number 36 as 13 one number I can take 13. Okay, now 6 minus 3 will give me 3. 3 minus 1 will give me 2. Okay, so you understood what I have done? I have taken one odd prime number, that is 13, and I have tried and subtracted this number. I'll get 23. And now we know that 23 is odd also and it is prime also. So we can say that we can express this 36 as the sum of two odd prime numbers, and those numbers are 13 and 23. Right? So likewise, we can do question number 2 also. It is 42. So let us again express this as a sum of two numbers. So how we can do this? First number, let me take 11. I have taken first number as 11. Now let me subtract 11 from 42. I will get 2 minus 1 as 1. 4 minus 1 as 3. 31. And kids, we know that both 11 and 31 are odd also, and they are prime number also. So we can express 42 like this. Next we have, now these two questions are homework for you. Okay, same way you have to do these questions. Express each of the following odd number as sum of three odd prime numbers. So now here, instead of one number, you have to use three odd prime numbers. So kids, I'm giving this to you as a homework. This is very easy. You have to identify three terms here. Three terms which are odd and which are prime numbers also. Okay, so the first question here, I'm doing it for you kids. We can express this as sum of three numbers, right? So let us try this with 31. How we can express 31 as the sum of three odd numbers? So first number I'm taking here as 11. Okay, so I'm just writing here answer 13 A part. Okay, 31. This is this plus this plus this. First number here also I'm taking 11. So when I'll subtract 11 from 31, I will be left with 20. Now I have to write two numbers here which should be odd and prime, and the sum of those two numbers give us 20. So we can use 17 and we can use 3. So 17 plus 3 will give us 20. So if we see this all together, we can break this 31 into 3 odd prime numbers, and they are 11, 17 and 3. Okay. So similar way you have to do all the 3 next questions also. Next, go to question number 16. In question number 16, express each of the following number as the sum of twin primes. So kids, we have done this. What are twin prime numbers? They are the numbers, the difference between the two numbers are 2, right? The difference between the numbers, the factors are 2 here. So we have already done this. So again, I'm leaving this as a homework for you. Now, find the two numbers whose sum is 14 and whose product is 48. So question number 17, kids, let's do this. 48, I can express it. Let us see the number of different ways where how we can express 48 as. So I can write this as 12 into 4, right? But when I will add 12 with 4 because it says that its product should be 48, which is true, but the sum should be 14. So let me try and add. The sum is 16, so discarded. We cannot take this. Next, what we have here is we have 2. Okay, we have 2, and then we have 24. 2 and 24, the sum will give us 26. Again, it is discarded. Next, what we have here is we have 3 and we have 16. If I add, I'll get 19. Again, it is discarded. Then I have 4 and 12, which is 16. Again, this is discarded. Next, we have after 4, 6 and 8. So we have 6 and 8. This will give me 14. Okay, so if we'll add these two numbers, it will give us 14. If we multiply, it will give us this product. This is also done, kids. Now find two numbers whose difference is 5 and whose product is 36. So kids, this is very easy. What are the two numbers whose difference is 5 and whose product is 36? What we are going to do here is we have to again find the factors. Okay, let's start with 2. We have 2 multiplied by 18, right? So the difference is not 5. So this is discarded. Again, next we have 3. With 3, we have 3 and 12. Again, the difference is not 5. This is also discarded. Then we have 4 and 9. So the difference between 4 and 9 is 5. So this is the number. So the two numbers are 4 and 9 here. So next we have true and false. Let's see. 1 is the smallest prime number. So kids, we know it's false. It's neither prime nor composite. If a number is prime, it must be odd. This is wrong. 2 is even and it's a prime number. The sum of two prime number is always prime number. That is, if we add two prime numbers, it will always give us a prime number, which is again false. Okay. Next, if two numbers are co-prime, then at least one of them must be a prime number. It says that if two numbers, they are co-prime, then at least one of them should be a prime number. Here, so again, this is true, right? Because the co-prime numbers are the numbers which do not have anything common except 1. So this is true. One of them should be a prime number. Now, the product of two prime number is always a composite number. The product of two prime number is always a composite number. So kids, this is true because then it will have the factors. The sum of two prime numbers is always a composite number. We have two prime numbers, 2 and 5, but the sum is again a prime number, that is 7. So this is also false. This we have already done, kids. Most of this true or false we have already covered. Now, a number and its successor are always co-prime to each other. So it says that supposedly we have a number. Let's say I have a number 4 and then I have a number 5. Now, these two numbers, they have always co-prime to each other. That means they will always have one as common. So let's see this, kids. With 4 and 5, we have one common, which is true. With 5 and 6, again, we have this one common. Again, that is true. Now, coming to 8 and 9, again, one is common. 9 and 10, again one is common. So yes, in most of the cases it is true. Now, two consecutive numbers cannot be both prime numbers. So this is false because 2 and 3, they are consecutive and they are prime also. Okay. Next, fill in the blanks. One is neither composite nor prime. Nor composite nor prime. A number have exactly two factors is called a prime number. A number having more than two factors is called a composite number. The smallest prime number is 2. The smallest composite number is 4. Done? So kids, we are done with the exercise 4A of RS Agarwal, and in our next class, we'll take the next exercise of this chapter. Okay, so I will see you all in the next class now.